That setting is suboptimal. Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to talk about steam engine valve timing. I'm going to be using my current project engine as a model, but we're going to be talking about things that should apply to any steam engine for which you need to set proper valve timing. So let's go. Here's the sample engine that we're going to work with. Take a listen to it. That's basically the sound that you're aiming for. I'm not going to claim this engine is perfectly tuned, but it's running relatively evenly. There's no clacking or rattling in the mechanism, and you can hear nice, soft, compressed gas noises at each end of the stroke. So you've just finished building your engine and now you want to get it running. So step one is to make sure that the piston travel is correct in the cylinder, because nothing else we do will be right if it isn't. So I'm removing the cylinder head and I'm removing the piston. You just want to measure the inside depth of the cylinder there from the inboard head to the outer surface. And I'm going to compare that to the measurement of the length of the cylinder between the machined faces, and that tells me how much space is being taken up by the inboard head. And now I can put the piston back in and wind the piston all the way down to the end of the cylinder and measure the depth again. Then I wind the piston out and I measure that space. And lastly, you can measure the length of the piston. Now you can get all of these numbers from the drawing, of course, assuming you built everything perfectly, but it's better to measure what you actually built and not what you should have built. Now don't worry about the specific numbers on this diagram or the units, they don't really matter, but the point is, using all those measurements that you took, you can deduce that 33 thou measurement in the lower left as the space at the inboard head of the piston, and you can then calculate what x should be. You can measure what you have now and then adjust it so that x and that 33 end up at the same value. Now I can thread it in or out of the crosshead as needed to correct the distance there so the gap at both ends of the cylinder is the same, and then tighten up that jam nut. And then I'll double check that measurement and then reinstall the cylinder head and of course run the piston back and forth by hand and make sure it isn't hitting either end of the cylinder. Now, time to get into the steam chest and look at the valve, the reason that we're here. Like the piston, the valve has to have the correct range of motion. So I'm running it back and forth and I want to make sure that it covers the same distance at each end. Now since this steam chest was machined internally, I know that valve ports are the same distances from the ends, so I can just measure the distance to the valve from each side of the steam chest. Now on this engine, to adjust this, I take out the pin there and I turn the valve rod, and that moves the position of the valve left or right as needed. Different engines will be different in this regard, but there will be some way to adjust the valve on that valve rod. And then I can put the pin back in and double check it. Now if the steam chest is not machined internally, you might have to try and measure the distance to the ports at one end, but the point is that the valve covers the ports the same amount at each end as it goes through its range of motion. You may need to adjust this linkage in more than one place. In my case, I had a collision here on that jam nut with the gland packing nut on the valve rod, so I had to make the rod shorter down here with this other set of threads and jam nut. This is the basic steam cycle from which steam engines derive their power. Now I know you can't really read these diagrams. Forgive me, this is a 1976 reprint of a book from 1899, but I show you this just to illustrate that this is actually a really deep topic that you can go deep on if you are so inclined. So you can see the basic 4 phases of the steam cycle there: admission, expansion, exhaust, and compression. And the circle graphic there is commonly used to illustrate valve timing as the crankshaft travels around. And on the right is a graphic illustrating the effects on the engine's performance using different amounts of these different phases of the cycle for different valve timings. Now, for getting a basic model engine running, you don't really need to know all that. I will explain a few of these terms as we go, but rest assured you don't have to do all of the math just to get your engine running. Okay, let's set the timing. So take a look at the crankshaft there, and I'm going to rotate the engine in the direction I want it to run until the crankshaft is at front dead center or top dead center. Now I can loosen the set screw on the eccentric hub, and now you can see how we can rotate the eccentric hub independently of the crankshaft orientation. And this is how we set the timing. So I'm going to rotate this hub again in the direction the engine is going to run. You always rotate these parts in the direction the engine will run to account for backlash, and you want to set it at 90 degrees to start. So the crankshaft is all the way forward and the wide part of the eccentric is pointing straight up. And this determines the direction that the engine runs in. If the valve is at 90 degrees, it runs in one direction. If it's at -90, it runs in the other. Now, traditionally, steam engines run what might be considered backwards. You want the top of the flywheel moving away from the load, and that's for two reasons. One, so that the forces of the crosshead are pushing down on those rails where the structure is more robust, and also because if you're driving a flat belt with the flywheel, you want the load to be pulling on the top of the belt and the bottom of the belt is slack, so that they don't interfere with each other. Some engines will run in this position, most will not. Most need lead on the valve. So that's what I'm going to set next. So what I'm going to do is I'm going to advance the eccentric again in the direction the engine is going to run until that valve just starts to expose the first steam port. So it's just cracking that port right there. This is just a basic rough valve lead setting, and this should be enough to get the engine running. So the angle that you now have between the crankshaft and the valve eccentric is the lead angle. Pay attention to which direction the valve is moving though. If I put the valve in this position, it looks just like we had before with the same amount of lead, but the valve was going the wrong way. So you got to make sure that the valve is wound all the way back over center and is coming back in the same direction the crankshaft will be turning when it exposes the valve port. So this is a proper lead setting. So there's two settings that both look the same, one correct, one incorrect. Why does an engine need lead though? Well, lead is what gives the steam time to get into the cylinder and start the expansion before the power stroke on that end begins. So it does two things. It gives the steam time to get in there, and also by admitting the steam a little early, it creates a cushioning effect on the piston and decelerates it at that end of the cylinder. It's also somewhat analogous to cam advance timing in an internal combustion engine, where the higher RPM you're running, the more time you need to give the gases to get into the cylinder. But lead is also somewhat dictated by valve lap. There's two kinds of lap in a steam engine valve, steam lap and exhaust lap. And this is how much the valve overlaps that particular port when it's sitting in this mid position. So the amount that the valve is going to need to move to start uncovering the steam port is the steam lap. The exhaust lap on the other end dictates how much time that steam is going to get to spend inside the cylinder expanding. What's different about steam than compressed air is that a lot of the energy to drive the engine comes from the expansion of the steam. It's not just the pressure of the steam going in. And expansion is where all of your efficiency comes from. So on like small switching locomotives, they're going to have a lot of exhaust lap because they want to draw as much expansion energy out of that steam as they can. But at higher RPMs, exhaust lap becomes a problem. So mainline locomotives often have negative exhaust lap, where there's actually a moment where both exhaust ports are open at the same time, just to maximize the amount of time that the exhaust steam has to get out of the other end of the cylinder when running at high RPM. Now, we can't actually control the lap. It's dictated by the size of the valve and the positions of the ports, but it's helpful to understand the role that it plays. So lap and lead, those are your two important concepts for tuning steam engine valve timing. So at this point the engine should run, but take a listen to it. You hear how it's kind of lumpy? There's more of a steam noise at one end than the other. The goal is to even that out. You want the same soft psh noise at each end. And since we started with minimal lead, the answer for now is always going to be more lead. So I'm going to advance the eccentric a little bit past where we had it. Now, if you go too far or you go the wrong way, this will happen. The engine gets even lumpier. You can see that it's barely making its way around. And of course, if you go way too far, the engine won't run at all. And if you get lost, you can always pull the steam chest off and reset it back to 90 degrees with the basic lead again. So we'll adjust it back the other way a little bit, and you just keep going back and forth until you close in on that sweet spot to where it sounds very soft and runs very smoothly. Quick sidebar, you just saw me move the valve against the direction of rotation, which previously I said don't ever do that. Well, you can do that if you take out the backlash in the valve train. Just like any other mechanical system, like a slide on your lathe, if you move back further than you need to and then come back in to take up the backlash, then make your adjustment, you can move in the other direction, and it makes it a little quicker than going all the way around every time. Another symptom of the timing being off is if there's any kind of banging or clacking in the mechanism, because if the steam isn't being admitted at the exact right moment, it can act as kind of an air hammer on the mechanism, and any slight slop that you have anywhere will be amplified, and it'll sound like the mechanism is clicking or banging. Now obviously nothing should actually be loose in the mechanism, but assuming it's all properly built, if you hear clicking, it can be down to valve timing. Now this tuning isn't perfect. There's still a very slight imbalance here. Take a listen. But I think that's very, very close. Now, before you get too crazy here, make sure you're done building the engine, because in my case, I'm still going to paint it and make a base and do lots of other things, so this engine is going to come apart a bunch more times, so it would be a waste to spend an hour tuning in this valve timing absolutely perfect right now. Let's talk about my setup here that I'm using for this testing in case you're interested. So the air line comes from the compressor and it goes into this ball valve here, and then it goes into a low pressure regulator. You need a regulator designed specifically for like sub 10 psi pressures. And then I've got a pressure gauge on it here. And now most of these parts are easy to get at any big box store. The pressure gauge here though, this was the trickiest part. It's somewhat difficult to find a pressure gauge that reads correctly at very low pressures. So this is actually a tire pressure gauge for garden tractors because they have very low tire pressures in them. So this thing will actually read correctly all the way down to 1 or 2 psi. You can't use something like an automotive tire pressure gauge because the bottom several marks on those are decorative. They don't read correctly at low pressure. And then on the end here we have a basic silicone tube. Again, the pressures are so low here that you don't need anything more than this to supply the air. And a zip tie is plenty sufficient to hold the connection on there. The next tip is make sure that you have all the gaskets installed before you set the timing, because if you're leaking air at one end or the other, it will mess up the timing. So to make these gaskets, I'm using the gasket material that came with the kit, and I just trace the head, and then I use a regular old punch to punch out the holes. If you're on a soft surface there, then any regular punch will work as a hole punch. And then I'm also tapping the casting itself, and that leaves an impression of the shoulder on that cylinder head in the gasket material there, so that I can see where to cut. And then I cut out the center first with an X-Acto or a razor blade so that the mass of the paper is still there to support it while I do this. And then finally I just cut out the outline with scissors. And there is our gasket ready to install. These are basic paper gaskets and they work okay. I'm not a huge fan of them, but the material came with the kit, so I'll use it for now. And just like on a full-size engine, make sure to tighten the cylinder head bolts evenly so that the gasket is correctly compressed. You also need to pack the glands. Traditionally, this was done with graphited yarn. This kit comes with the modern equivalent. It's kind of a Teflon cord. It has the consistency of plasticine, sort of. It acts like clay. So you just kind of want to measure one wrap, cut it to length, and then stuff it in there, kind of get it started. And you want just a little bit of overlap there. One lap around is sufficient. And then kind of stuff it into the gap there with a punch that isn't sharp so that you don't damage the cord. And if there's excess there, you can just trim it off. And then with that started in the hole there, now we can slide the gland packing nut in there and give it a little squish. So the way this works is you just start with it fairly loose, and then if it's leaking, tighten it down a little bit until it stops leaking. If you over tighten it, then you'll generate a lot of friction on the piston rod and the valve rod, and they won't move very well. So just snug it down a little bit at first and wait to see how much it leaks. And then the valve is done the same way. It's a little bit trickier because it's a lot smaller, and I actually had a lot of trouble getting the correct amount of cord here because it's such a small packing area there. Now I'll shut up and let you listen to the engine here for a little while. Once it's running well, it's fun to put it on the finger dyno and see how much power it'll make. So I've got my finger on the crankshaft there for some load, and I'm turning up the pressure with the other hand. It gets to the point where I can't stop it with the crankshaft anymore, so I got a hand on the flywheel. And this is about 20 psi, and it's taking quite a lot of finger strength actually to slow it down. You can listen to it and hear how hard it's working. Now, when you unload the engine, you got to be very careful to turn that pressure down very quickly or at the same time because you don't want to overspeed the engine. This is why steam engines need a governor. Pressure has to match load. So this is my method for tuning valves. There is another way to do it though that I want to draw your attention to. I'm going to link you down below to Keith Appleton's excellent video on this topic. He does it entirely by ear with the flywheel held still and just listening for the steam admission. And I think it's a very clever way to do it if you have a good ear. I do not have a very good ear, so I do the method that I showed here, but Keith's method is great, so go watch his video as well. And if you're interested in designing engines, well, you're going to need to get a book on the steam cycle and steam valve design concepts. But I hope this gave you a little taste of what's involved. Thank you very much for watching. If you like these videos, throw me a little love on Patreon maybe, and I will see you next time.